Welcome to This Explainer. Today, we are cracking open what is arguably one of the most notoriously rigid make-or-break topics in the entire Cambridge AS and A-Level 01 Mathematics 9709 syllabus. We are diving deep into Section 3.1, Algebra. And more specifically, we are stepping into the high-stakes world of partial fractions. We're talking about linear factors, repeated factors, and those absolute trapdoors known as irreducible quadratic factors. Now look, mastering this requires so much more than just memorizing a few algebraic formulas. The syllabus demands that you weave that raw foundational knowledge into the higher-order analytical thinking that Cambridge examiners are actively hunting for. So, over the next little while, we are going to completely break down the most common student pitfalls, we'll decode the core examiner principles, and we are going to help you engineer the absolute perfect, top-tier response so you can walk into that exam room with total confidence. I really want you to consider the sheer weight of this statement coming straight from a Cambridge senior examiner. They stated that partial fractions appear in every examination series. Literally, every single one. Think about what that actually means for your prep. Partial fractions are not just some standalone mathematical island that you can choose to skip if you're running out of study time. No, they are the fundamental gateway to the rest of the paper. You absolutely cannot execute complex integration without first breaking down the fraction. You can't expand binomials with rational powers without them. You can't solve advanced differential equations later on without them. Whether you are facing down a simple linear denominator, a really deceptive repeated factor, or one of those irreducible quadratic factors, the examiner is testing your structural discipline right out of the gate. If you drop the ball here, you don't just lose the 3 or 4 marks for the partial fraction question itself. You hemorrhage the subsequent 6 or 7 marks in the integration follow-up question because your foundation was flawed. It's a domino effect. The stakes literally could not be higher. But don't worry, we are going to lock down every single one of those marks today. So, here is our strategic roadmap for the session. We are going to start with the core exam principles, then move into our procedural framework. After that, we'll break down exactly how to secure the all-important method mark, review the top examiner warnings, and finally, evaluate our evidence quality. Let's get right into it. Section 1, Core Exam Principles, Decoding the Assessment Objectives. Okay, so the exact cognitive domains demanded by the Cambridge rubrics are divided into 3 main areas: knowledge and understanding, application, and analysis. Now, most students make the fatal mistake of thinking partial fractions fall entirely under that first category. They think it's just mere rote memorization of the algebraic forms. But Cambridge places an immense, heavy weight on application and analysis. Let's talk about command words, because this is where the game is won or lost. When the exam paper uses the command word find, they want the precise mathematical values of your constants. Pretty straightforward. But when they use the phrase hence or otherwise, they are actively shifting the cognitive domain on you. Hence means you absolutely must use the partial fractions you just derived in Part A to execute the integration in Part B. I see students all the time completely ignoring the word hence and trying to use some convoluted substitution method instead, completely starting from scratch. And what happens? It triggers an immediate, non-negotiable marking penalty. The examiner's grading grid slams shut. You get 0 method marks, even if you miraculously stumble into the right final answer, simply because you failed to satisfy the explicit instruction of the command word. So that brings up a really provocative question. Why do students find the distinction between key terminology so incredibly hard to grasp under pressure? Well, to explain this, I want you to picture 2 types of students studying in a shared suite right now. We'll call them Alex and Sam. Now, Alex represents the classic Cambridge paradox of fact overloading. Alex knows every formula but lacks structural precision. Alex just writes down the course setup and skips all the intermediate steps to save time. If Alex sees a quadratic factor like x squared plus 4 in the denominator, they correctly remember to put ax plus b in the numerator, but then they jump straight to equating the coefficients mentally and just scribble down the final answer. But by doing that, they are blowing right past the explicit restrictions of the paper. When the exam says show that the partial fraction takes a specific form, you absolutely cannot just jump to the final coefficients. You have to prove the algebra step by step. Now, on the flip side, we have Sam. Sam writes incredibly fast, but gets bogged down in proving every single tiny algebraic expansion, building these massive paragraphs of math, and ultimately running out of time for the rest of the paper. Neither approach works. You need a completely balanced strategy. Which brings us perfectly to Section 2, the procedural framework, or as I like to call it, systematizing your math. When you are staring down a high-tariff, multi-part past paper question, you need a bulletproof procedural framework. Let's walk through a concrete example. Take the expression 5x squared plus x plus 6, all divided by the product of 3 minus 2x and x squared plus 4. Step 1. Identify the key elements. We have a linear factor in the denominator, which is 3 minus 2x, and we have an irreducible quadratic factor, which is x squared plus 4. Step 2. Apply the principles by setting up your constants. You put capital A over the linear factor, plus the quantity capital Bx plus capital C over the quadratic factor. Now here is step 3, and it's absolutely critical. Before doing a single ounce of mental math, you must execute by writing out the full identity equation. You must explicitly state on paper that 5x squared plus x plus 6 is identically equal to your new algebraic setup. You need to use that 3-lined equivalent symbol. If you miss this baseline structural step, you instantly lose your first method mark. Writing that baseline out secures your entire analytical framework. Once that's written, you move to step 4 and 5. Execute the analysis by substituting values or equating coefficients to isolate your constants. Verify the logic and present the final result in the appropriate format. Now, let's go back to our students, Alex and Sam, who are debating how to write down their final answer. It is absolutely crucial to understand the difference between raw textbook data input, which is Alex's strategy, and presenting flexible analytical links, which is Sam's strategy. Imagine you've done the working out. A messy web of raw algebraic expansions might give you the right constants. Let's say you figure out that A equals 2, B equals -1, and C equals 3. Alex wants to just write A equals 2, B equals -1, C equals 3 at the bottom of the page and call it a day. But just listing out those raw variables completely fails the presentation requirement of the exam. The syllabus explicitly requires presentation in the appropriate format. Listing the constants isn't the answer when the question explicitly asks you to express the algebraic fraction in partial fractions. You must present a flexible analytical link back to the prompt. You do this by rewriting the entire final expression with those evaluated constants properly formatted back into the actual fractional structure. Sam hits the nail on the head here by rewriting the whole thing out. Section 3. Securing the method mark. We're doing a mid-video strategy upgrade here, focusing entirely on process over result. Actually, quick pause for a strategy check. Before we unlock this top band paragraph structure to help you crush your upcoming sessions, I need to make sure your revision feed is perfectly optimized. Take a second right now to subscribe to the Ace the Exams at Ace the Exams and enable all notifications. You definitely don't want to miss our weekly Cambridge exam breakdowns, whether you are sitting for IGCSE, O-levels, AS, or A-levels. Okay, let's get back to it. Let's dive really deep into the method mark strategy. In Cambridge mathematics, marks are awarded primarily for demonstrating process, clear working, and logically structured reasoning. It is absolutely not just about the final numerical result. Think of it like this. Imagine you've correctly identified your constant structures, but in a rush because the clock is ticking, you make a tiny, silly arithmetic error with a negative sign really early on in your working. If this exam were purely an accuracy test, you'd score a hard 0. But if you deployed our universal structural matrix, meaning you wrote down the identity clearly, you explicitly stated the word substitute x equals 1.5, and you explicitly wrote down the phrase equating coefficients of x squared, then the examiner's hands are tied. They have to award you an M1 mark for the correct partial fraction form and another M1 mark for a valid method of finding the constants. They will only penalize the final A1 accuracy mark. So even if your calculator betrays you under extreme pressure, your documented logic secures the vast majority of the point yield. That is a game changer. Moving on to Section 4, Top Examiner Warnings. Consider this an interactive visual workshop to test how you process data under pressure. When we scan the historical data of common errors across linear, repeated, and quadratic fractions, a massive, glaring core trend emerges. Are you ready for it? It's an absolute failure by students to match the degree of the numerator to the denominator. Students repeatedly, year after year, put a single constant a over a quadratic factor, or they completely forget the ascending powers when dealing with repeated factors. This isn't just a minor slip-up. This is the exact structural failure that principal examiners are warning us about in their confidential reports year after year. Let's break down the exact blacklisted mistakes from those principal examiner reports that consistently drain student scores globally. Mistake number 1, students forget to include the proper format. They just write floating equations without the equivalence identity sign, linking everything together. Mistake number 2, they forget to check format and presentation, effectively leaving their final answer as a giant, jumbled mess of algebra instead of distinct, clearly separated fractions. And mistake number 3, which is huge. Answers are generic and not specific to the context. Now, what in the world does context mean in a pure math paper? Well, It means if the partial fraction question was actually setting up a binomial expansion for part B, and your derived partial fraction has a negative sign in the denominator, you completely failed to extract that negative out to format it as 1 minus x. And you need it to look like 1 minus x for the binomial expansion formula to even work. You solve the math, but you ignore the broader context of the exam paper. It is incredibly easy to step right into an examiner trap. For instance, if a student writes a generic b over x minus 2 for a repeated factor, instead of ascending the power to make it squared, they trigger the trap instantly. They completely fail to ascend the power. And the consequence? This renders every single subsequent line of mathematical working completely invalid. Poof, gone. A 7-mark question instantly becomes a 0 because the foundation was mathematically unsound. The target you should be aiming for is total structural precision. A justified, proper convention recognizes that since x minus 2 is a repeated linear factor, the expansion must legally account for all ascending powers. It has to be a over x minus 2 plus b over the quantity x minus 2 squared plus c over whatever the remaining linear factor is. That step-by-step structural precision is exactly what examiner compliance looks like in the real world. Section 5. Evaluating evidence quality. We've made it to the ultimate recap. To achieve those highly coveted top-tier marks, you must prioritize analytical depth over superficial breadth. Analytical depth means you actually have to verify your results. Let's say you finish your partial fractions and you miraculously have 5 minutes left in the exam. What do? You do a verification check. Plug a super simple value, like x equals 1, into the original massive fraction the paper gave you. See what number comes out. Then plug x equals 1 into your brand new separated partial fractions. If those two numbers don't match, you've just found a hidden arithmetic error beneath the surface, and you now have the power to fix it before the examiner ever even sees it. It's like having the answer key right there with you. Furthermore, writing fast doesn't mean skipping your foundational identities. Explicitly stating your methods guarantees that if your final evaluation goes completely sideways, your methodology still secures the marks. Cambridge's higher-order objectives demand deep, logically justified, and actively verified mathematical arguments. To finalize this masterclass, I am turning this entire session into 3 universal Cambridge operational rules that will strictly enforce proper headings, terminology, and clear annotation for you. Rule 1, the 3-step question scan. Before your pen even touches the exam paper, you decode the denominator. Is it linear, repeated, or quadratic? Then decode the command word. Is it find or is it heads? Rule 2, the marks per minute formula. In a 9709 paper, you have roughly 1.5 minutes per single mark. A 7-mark partial fractions question warrants exactly 10.5 minutes of your time. If you are stuck staring at the algebra at minute 12, you are actively bleeding time from the rest of the paper. Write your method down clearly, secure the M marks, and move on. Rule 3, the post-writing compliance audit. This is your mental format checklist. Did you state the identity? Did you explicitly show your substitution or equating method? Did you rewrite the final expression with the evaluated constants correctly formatted? If you rigorously apply these 3 operational rules, the marking grid will yield top marks for you, for sure. Here is a final provocative thought for you to carry into your next study session. Are you simply memorizing the math, hoping for the best, or are you actually engineering a structural performance that the examiner has absolutely no choice but to award full marks to? Think about it. Now get to work, make sure to subscribe to Ace the Exams, hit that notification bell for weekly grade masterclasses, and drop a comment below sharing exactly which Cambridge subject and level, IGCSE, O, AS, or A-level, you're preparing to conquer next. See you next time.